Tomorrow morning, the ecosystem defending your intestines is gone. Every gut bacterium has vanished. But here's the disturbing part. You probably wouldn't collapse. You might wake up feeling completely normal while an invisible failure has already begun. Before we follow it, let's be precise. Your gut also contains viruses, fungi, and other microbes. In this scenario, only the bacteria disappear. Scientists have never sterilized a healthy adult gut, so we'll combine human antibiotic studies with evidence from germ-free and bacteria-depleted animals. Wherever the science becomes uncertain, I'll tell you. Most of the bacteria in your body live inside the colon, not 10 times more than your human cells. That famous claim is outdated. The best estimate is roughly 38 trillion bacterial cells across the body, about the same order as your 30 trillion human cells. Overnight, the busiest biological city you carry becomes almost empty. During the first meal, your stomach and small intestines still work. Human enzymes continue breaking down protein, fat, starch, and sugar. You're not suddenly unable to absorb food. The first major failure happens farther down when fiber and resistant carbohydrates reach the colon. Your own enzymes cannot finish that job. Normally, bacteria ferment that leftover material. Think of them as a chemical factory converting fiber into short-chain fatty acids, acetate, propionate, and especially butyrate. These molecules are not digestive trivia. They help feed colon cells, influence metabolism, support mucus, and send signals to the immune system. Now the factory is silent. Within hours, production falls. Gas production would change too, so you might briefly notice less familiar bloating. But that is not a health upgrade. Undigested material is moving through a system whose chemistry has abruptly changed. Depending on your diet and your body, bowel movements could slow, loosen, or become irregular. Science cannot honestly promise one universal response. Now watch the wall of your colon. Its cells are joined by tight junctions and protected by mucus. Butyrate helps power those cells and supports the proteins that hold the barrier together. Losing bacteria does not instantly tear holes in the gut. Instead, you have removed part of the maintenance crew. Over the next days, the wall becomes less resilient. The immune system notices the silence. Friendly bacteria normally provide constant signals that help calibrate local defenses. They influence antibodies, such as IgA, and help regulate immune cells rather than simply switching immunity on. Germ-free animals show major immune differences, but they developed without microbes from birth. In an adult, the short-term human outcome is less certain. The clearest danger is an ecological one: empty space. Healthy gut bacteria compete for nutrients, occupy attachment sites, alter bile acids, and produce substances that restrain invaders. Remove them, and you remove colonization resistance. A pathogen still has to reach you, but when it does, the usual crowd blocking the door is gone. Human experiments show how dramatic that opening can be. In a controlled study using a non-toxin-producing strain of C. difficile, colonization occurred in about 5% of participants without vancomycin pretreatment. After 5 days of microbiome-disrupting vancomycin, it reached 84%. Your imaginary total disappearance would create an even emptier playing field, though the exact risk cannot be measured. By the first week, the visible problem could look ordinary: diarrhea, constipation, cramps, appetite changes, or nothing obvious at all. Underneath, fermentation products remain low, bile acid processing has shifted, and opportunistic microbes or fungi may begin expanding. The danger is not that your body forgot digestion. It is that a stable ecosystem has become an uncontrolled vacancy. What about vitamins? Some gut bacteria can manufacture vitamin K2 and several B vitamins. Losing that capacity matters, but it would not make you bleed the next morning. Food remains the main source for many vitamins. Body stores vary, and not every vitamin made in the colon is absorbed equally. Deficiency would be a longer-term, person-specific risk, not an instant movie effect. And your brain? The gut communicates through immune signals, microbial metabolites, hormones, and nerves. Remove bacteria, and those messages change. Animal studies suggest effects on stress responses, serotonin biology, and behavior, but we cannot accurately predict that a healthy adult would become depressed, confused, or transformed on a fixed schedule. That claim would outrun the evidence. There's another twist. In normal life, your gut would not remain bacteria-free. The next bite of food, the next touch of your mouth, and contact with other people or surfaces would introduce new bacteria. Recolonization could begin quickly, but rebuilding a community is not the same as restoring the original city. After ordinary antibiotics, many healthy adults regain much of their bacterial richness over weeks or months. Yet some species disappear for longer, metabolic output can change, and the community may settle into a different state. If every bacterium vanished, the race back would be far more chaotic. Early arrivals could shape which species find space later. Doctors can sometimes rebuild damaged microbiomes using carefully screened fecal microbiota treatments, especially for specific recurrent infections. That is a controlled medical procedure, not a home experiment. A random probiotic capsule contains only a tiny selection of strains and cannot instantly reconstruct the thousands of relationships that made your original ecosystem stable. So would you survive? Probably, at least at first. Germ-free animals can live in protected environments with specialized care. But a previously normal human suddenly stripped of gut bacteria would face unstable digestion, weaker colonization resistance, altered immune and metabolic signaling, and a dangerous race to rebuild the ecosystem before the wrong organisms take control. The real surprise is not that bacteria help you, is how much of you depends on a crowded world you never see. You do not simply carry a gut microbiome. Every day, you and that ecosystem keep each other alive.